Okay, so in this lesson, we're going to look at simplifying expressions involving the nth roots of 8 to the n. So basically, we're going to be finding, let me go ahead and write this down for you, finding the nth root of 8 to the n. So that this part here, this is the notation. So finding the nth root of 8 to the n, where a is a real number. So where a, this a here, is a real number. And remember, a real number can be positive, negative, or zero. Okay, so let's start with this idea. So remember, so let me go ahead and write this as recall. So if we have the square root of 9, you all know that the square root of 9 is 3, because 9 is a perfect square, and square root of 9 is 3. And remember, the square root of 9 is 3 because 3 squared is equal to 9, right? So this 3 is what you see here. You also agree, and I'm going to write this way now. You also agree that if I rewrite the square root of 9 as the square root of 3 squared, do y'all also agree that's equal to 3? Because isn't 3 squared the same thing as 9? And so the square root of 9 is 3, so the square root of 3 squared is also equal to 3. If I have this, though, now you got to be careful. If I have the square root of negative 3 squared, what do you think that's equal to? The square root of negative 3 squared. Do you think it's 3, or do you think it's negative 3? Well, you got to be careful here because remember the negative 3 squared, that means negative 3 times itself. So remember, that means the square root of negative 3 times negative 3, and negative 3 times negative 3 is a positive 9, and the square root of 9 is 3. So you have to be careful. You have to be careful when you're looking at this situation and a is negative. So when a is negative, we're going to discuss this a little bit more, but when a is negative, you have to be careful. Okay, so let's go ahead and simplify the following. So let's write this as simplified. Okay, now we're going to start with the simple one. So number 1, suppose I have the the third root, or the cube root rather, of 2 to the third power. So the cube root of 2 to the third power. Okay, first of all, if you do it the long way, you know that means that 2 to the third, so 2 to the third means 2 times 2 times 2, which is 8, right? And so this becomes the cube root of 8, and you all know that the cube root of 8 is just 2. Because remember, the cube root of 8 means what times itself 3 times is 8, and so that's 2. Now, the point is this now. Do you see that the answer is 2 and that base is 2? So notice the index and the exponent are the same. You see that? The index and the exponent are the same. And so that's the situation we're dealing with here. So the index and the exponent are the same. So these have the same number. Okay? And so the question is, what is the rule? What is the rule when we have something like this? So let's look at an example first. So let's look at this one. Suppose I had the fourth root of, let's say, 3 to the fourth power. So what do you think that is? If you can make a conjecture from here to there, or even from any that we've done in the past, what do you think that is without having to do all of this? Do you think it's 3? All right, so you know that 3 to the fourth means 3 times 3 times 3 times 3. And then 3 times 3 is 9. This 3 times 3 is 9, and 9 times 9 is 81. So this becomes the fourth root of 81, right? And then notice that the fourth root of 81, even if you did not recognize that it is 3, because remember, this means what times itself 4 times is 81. Well, you just saw it. It's 3 times 3 times 3 times 3. So it's 3. you could have just used your calculator. You could have just said, all right, I'm going to take the fourth root of 81. So let's remember how to do that. So the fourth root, so remember you're gonna do the 4 first. You're gonna say 4, and then you're gonna press second, and you see it's right here, and you see right there. And then you put 81, and you press equal, and you get 3. So the fourth root of 81 is 3. So I want you to recognize that this number here, the answer, is your base. Whenever the index and the exponent are the same, it is the base. Now you got to be careful. We talked about this. Whenever the base is negative and is being raised in even power, you have to be careful. You have to be careful. So here's the point I'm going to make now. Let's look at number 3. What if I had the fourth root of negative 3 to the fourth? So we know that the fourth root of 3 to the fourth is 3. What do you think the fourth root of negative 3 to the fourth is? Do you think it's negative 3? All right, so let's think about this. So remember the fourth root of negative 3 to the fourth. So negative 3 to the fourth means negative 3 times negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is 9. Negative 3 times negative 3 is 9. 9 times 9 is 81. So this becomes the fourth root of 81, which, see, these are the same now, which we saw is just 3. So this is where you have to be careful. You have to be careful. So whenever the base is negative, you cannot, and the index and the exponents are the same, you cannot just say it's the base, because the answer is not negative 3. You see it's 3. So if the base is negative and is being raised in even power, be careful. You're going to take the absolute value of this. So the answer is actually positive. Okay, so let's think about this. Number 4, what do you think this is? The sixth root of negative 2 to the 6th power. What do you think that is? Yeah, without doing anything else, you know the answer now. Is it negative 2 or is it positive 2? It's positive 2, because a negative number raised to an even power, a negative number raised to an even power is always positive. It's always positive. So you can't say that's equal to a negative number. That's equal to a positive number. So the sixth root of a positive number has to be positive, right? So you have to say it's 2. So basically what you're doing is you're taking the absolute value of negative 2 and you're getting 2. So here you're taking the absolute value of negative 3, and you're getting positive 3. All right, now let's look at this. So let's make sure you're understanding what's happening here. So here's the situation. Finding the nth root of a to the n. Finding the 8th root of a to the n. If n is an even positive integer, okay? So if n is an even positive integer, so positive 2, positive 4, positive 6, and so on, if n is an even positive integer, then the nth root of a to the n. Okay, so let's look at this. So you see how these are positive, even, 6, 6, 4, 4, 4, 4. This is not positive, this is not even, so I'm not going to look at number 1. But notice that when the base is negative, when the exponent and the index are even and the base is negative, we took the absolute value to get our answer. Base is even, we took the absolute value to get our answer. See that? So if I had, let's say, number 5, let's say this was number 5. Let's suppose I had the 6th root of 8 to the 6th power. So the 6th root of 8 to the 6th power. So you see, this is already even, right? I mean, this is already positive, right? So a positive raised to the even power is positive. And so the sixth root of a positive number is positive, so it's just 8. If I have the sixth root of negative 8 to the 6, negative 8 to the 6, it's not negative 8. Don't say negative 8. It's not negative 8. It's the absolute value of negative 8, which is 8. Okay? So going here, if n is an even positive integer, then the nth root of a to the n will be the absolute value of a. Okay? Whatever a is, you're going to take the absolute value of a. So if I go back here, see how I took the absolute value of negative 8? Here, if I take the absolute value of 8, I still get 8, right? So number 7, if I have the 8th root of negative 4 to the 8th power, and number 8, if I have the 8th root of 4 to the 8th power, what do you think the answer is for both? Well, right away, you know the answer for both is 4, right? Because you're taking the absolute value of negative 4 here, which is 4, and you're taking the absolute value of 4 here, which is also 4. So the answer is 4 in both cases. Now, don't leave the answer as absolute value. You got to actually, you know that the absolute value of negative 4 is 4. You know the absolute value of 4 is 4. So the rule is this: if n is an even positive integer, then the nth root of a to the n will be the absolute value of a. If n is an odd positive integer, okay, if n is odd, then you have nothing to worry about. Okay, watch. Then the nth root of a to the n, so if n is odd, I want you to think about this. Let's look at number 9. Suppose I had the cube root of 2 cubed, and then number 10, the cube root of negative 2 cubed. Suppose I had that. So 2 cubed, you know, is 8, right? So 2 cubed is 8. Y'all agree? And so I get the cube root of 8, which we know is 8. I'm sorry, 2, excuse me. Here, negative 2 cubed, a negative number raised to an odd power, is always negative. So a negative 2 times itself 3 times is a negative 8. So this becomes the cube root of negative 8. And you know the cube root of negative 8 means this: what times itself 3 times is negative 8? Well, a negative 2 times a negative 2 times a negative 2 is a negative 8. So the answer is negative 2. So when n is odd, it's just your base. So if the n, so if the index and the exponent are the same and they're odd, then it's just your base. If it's even, you have to take the absolute value. So the absolute value of negative 4 is 4. The absolute value of 4 is 4. Okay? So you have to be careful. All right, now let's write this down right here. So if n is odd, then the answer is just a. It's just a, whatever a is. Okay? Okay, now let's look at some examples. So the directions will say something like simplify. All right, so let's simplify. Number 1, let's suppose we have, actually this will be, so this is number 10 right here. If I can get to that page. So this is number 10. Let's do number 11. So let's write this as number 11. So number 11, let's continue simplifying. So let's suppose we had the 7th root of 9 to the 7th power. What do you think that is? So the index and the base are the same. So don't multiply it out. Don't use your calculator and say 9 to the 7th and come up with some number. That's not the idea. You need to recognize that if the index and the base are the same, and it's odd here, it's just 9. So the answer is 9. Number 12, if you have the 6th root of 4 to the 6th power, what do you think the answer is? It's just 4. And you know that's true. Come on, think about this. You know that's true because this whole thing right here means means what times itself six times rather. 1, 2, 3, 4, 5, 6. 6 times is 4 to the 6. Well, 4, right? 4. Because 4 to the first, remember, you multiply like base, you got exponents. 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. Right? Number 13, what if you had the seventh root of negative 3 to the seventh power? Okay, now that's where students get confused. They don't know whether to say negative 3 or positive 3 because of this rule right here. It's not an easy thing to understand at first. Okay, I agree with that. It's not an easy thing to understand. But what you got to remember is this: a negative number raised to an odd power is negative, right? Okay, and so you're taking the odd root of a negative number, which you know will be negative. So this right here means what times itself 7 times. 1, 2, 3, 4, 5, 6, 7 is negative 3 to the 7th. Oops, sorry. Negative 3 to the 7th, which you know is negative. Because a negative number raised to an odd power is negative. Well, so notice this is 7. You have 7 factors here, so you know you got to put a negative 3. So negative 3 times 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 negative 3 is negative 3 to the 7th. And so the answer is negative 3. But what if you had this, number 14? What if you had the fourth root of negative 3 to the 4th? That's where you got to be careful. So the fourth root of negative 3 to the 4th. Well, a negative number raised to an even power is positive. And so the square root of a positive number has to be positive. So you know the answer is going to be positive. But the question is, positive what? Well, let's think about this. Remember, this right here means what times itself 4 times is negative 3 to the 4th. Well, that's going to be positive, right? So you know that you can't put a negative 3 in here. Because if you put a negative 3 in here, that means you have to put a negative 3 here. But you know that can't be true. That's positive. So you got to think about, well, if this is positive, that means that this is 3 to the 4th. Negative 3 to the 4th means the same thing as 3 to the 4th, right? So you're going to put a 3 here. And so this has to be a positive 3. So it is confusing. That is confusing. So what you got to remember, though, is this. Whenever these the index and the exponent are even, then the answer is going to be the absolute value of this number. So you're going to say the absolute value of negative 3, which is positive 3. Okay? So be careful. It is a difficult concept at first. Okay, number 15. All right, in 15, suppose you had this. Now we're going to start looking at variables. Suppose I had the cube root of y to the third power. The cube root of y to the third power. Now you had something like this in a previous lesson a while back. And that's where you had to start looking at the absolute value. Remember, we saw absolute value a while ago. So the index and the exponent are the same, but they're odd. They're odd. And so according to our rule, whenever the index and the exponent are the same, the answer is just A. And it's odd, the answer is just A. If it's even, I've got to be careful. It's going to be the absolute value of this base here. Okay? So this is going to be y. Now remember, let's see why the absolute value is not needed. Now some students, they just put absolute value all over the place. You don't do that. If you put absolute, see, it's wrong to say this. Because y could be negative. We saw that a while ago. Look. Let me go ahead and write this. So watch. If I have the cube root of negative 2 cubed, you know the answer is negative 2. Negative 2. If I have the cube root of 2 cubed, you know the answer is positive 2. Because this is negative 8. The cube root of negative 8 is negative 2. This is 8. The cube root of 8 is 2. So for an odd, it's just your base, whatever y is. So it's just y. So if you put absolute value here, you're saying the answer is the absolute value negative 2, which is 2, and that's not correct. Okay, the answer is negative. So if you put the absolute value here, that means you're making it positive. All right. So if the index and the exponent are the same and it's odd, it's just your base. All right. Now let's look at this, number 16. Suppose I had the fourth root of y to the fourth. The fourth root of y to the fourth. Now that's where you have to be careful, because remember, this is even now. So the question is the answer just y? That's your question. Is the answer y? Well, let's think about this. Let's think. If I have the fourth root of negative 2 to the fourth, and then the fourth root of 2 to the fourth, well, you know that that 2 to the fourth is 16, and the fourth root of 16 is positive 2, right? And you know that negative 2 to the fourth is also 16, and the fourth root of 16 is positive 2. So you can't just say the fourth root of y to the fourth is just y. Because if you did that, you would say that the answer here is negative 2, and it's not. You got to say the absolute value of negative 2. So you have to put absolute value here, because this has to be a positive number, right? Your answer has to be positive. Your answer has to be positive. So if the base is negative and you don't do this, then you're saying the answer is negative. Because remember, y, if y is negative or if y is positive, raised to an even power, that's always going to be positive. And the fourth root of a positive number is always positive. Okay? Here, the odd root, the odd root of a negative is negative. The odd root of a positive is positive. So you take the base, negative 2, positive 2. A number, remember, not assuming it's not 0, a number either positive or negative raised to an even power is always positive. The fourth root, the even root of a positive number, or the root of any root of a positive number is always positive. So you have to make sure this is absolute value. All right, number 17. Let's look at 17. Suppose you had, let's say, the square root of 25x squared. So remember the product rule earlier that we learned in a previous lesson? I can write this as the square root of 25 times the square root of x squared, right? And we know that the square root of 25 is 5, and we know that the square root of x squared is x. But here's the question, is that the answer? You got to think of that, be careful. See, this is even, so you need absolute value here. Don't put 5 in absolute value bars, because it's positive already. Square root of 25 is 5. You got to put the x in absolute value bars, so you got to be careful. 18, suppose you had the square root of 36x squared. What do you think that is? Well, the square root of 36 times the square root of x squared. And so this would be 6 absolute value of x. 19, what if you had the cube root of 8x cubed? Cube root of 8x cubed. Well, that's going to be the cube root of 8 times the cube root of x cubed. That's positive 2. Now that's odd, so I don't have to worry about it. Since these are odd, I don't have to worry about absolute value at all. It's just x. So remember, if n is odd, don't worry about absolute value bars. Okay, don't worry about absolute value bars. So no absolute value bars. Okay, if n is odd, no absolute value bars. All right. 20. Let's look at 20. So number 20. All right, in 20, let's suppose we have this. We had, let's see, real quick. All right. Let's say we had the 8th root of y to the 8th. What do you think that is? The 8th root of y to the 8th. Well, that's even, right? So I got to put absolute value of y. What if I had, number 21, what if I had the fourth root of 16 y to the fourth? The fourth root of 16 y to the fourth. Let's say I had that. Well, again, that means the fourth root of 16 times the fourth root of y to the fourth. Well, the fourth root of 16 is 2. The fourth root of y to the fourth, be careful, that's even, right? So you need the absolute value of y. All right, let's see. Let's try this one. Suppose I had, number 22, suppose I had negative fourth root of y to the fourth. All right, what I would do there is I would cover up the negative for right now. Cover that part up. You know that the since that's even, you know that that's going to be the absolute value of y, right? And then just put the negative out in front. So there's your answer. Negative absolute value of y. 23, what if you had negative cube root of y cubed? Well, cover up the negative for right now. You know that since that's odd, it's just y. And then just put the negative out in front. Okay? 23, what if you had this? Suppose you had the ninth root of x minus 3 to the ninth power. Now, don't let that confuse you. It's just a binomial. But you know there that these are the odd, right? So it's just x minus 3. There's your answer, x minus 3. Now, what if it's even? 24. Suppose you had the eighth root of x minus 3 to the eighth power. The ends are even, right? So remember, if the ends are even, you need absolute value. So that's going to be the absolute value of x minus 3. So notice the difference. Okay, now remember why we need absolute value, okay? We need absolute value because this base, whether it's positive or negative, raised to an even power, that's positive. This is always going to be positive unless it's 0. But it's never going to be negative. And then the root of a positive number is always positive, so we have to make this positive. Here, depending on what x is, this could be positive or it could be negative. And so you don't put the absolute value here, because if you put this in absolute value bar, then you're making it always positive. All right, so that's why you need absolute value bars there. So remember again why we need absolute value bars. So if I have the 10th root of y to the 10th power, y to the 10th will always be positive, because if y is negative, raised to even power, that's positive. If y is positive, raised to even power, that's still positive. So that's always going to be positive. And then that means that the 10th root of a positive number is still positive. So if you put y there, remember y could have been negative, right? So now you're saying the answer is negative, but it's not, because a negative raised to even power has to be positive. And then make sure you understand that the relationship here. So if I had the 10th root of negative 2 to the 10th power, you know the answer has to be the absolute value of negative 2, which is 2, right? Because negative 2 raised to an even power, and even if you used your calculator, negative 2, watch, negative 2 in parentheses, negative 2 raised to an even power, in this case 10, gives us 1024. And so if I take the 10th root of 1024, see, that's positive, right? So our answer has to be positive. But if you still want to check, then you would say 10, remember 10th root, then press this button here, and then 1024, press equal, and you get 2. So you know the answer has to be 2. So when it's even, you need to take the absolute value. Okay? All right, now let me make sure, okay, let's try this one. Suppose we had the 26, suppose we had the cube root of 64x cubed. Well, we know that that can be written as a cube root of 64 using a product rule times the cube root of x cubed. Well, the cube root of 64, what times itself 3 times is 64, right? So that's going to be 4. And then the indexes are the index and the exponent are the same, and they're odd, so it's just x, 4x, not absolute value. See, if you put absolute value here, then you're saying that this is always going to be positive, and it's not, because what if x is negative? A negative raised to an odd power is negative, and the cube root of a negative number is negative, so that has to be a negative answer here. All right, so be careful. Know when you're going to do absolute value and absolute value bars. Know when you're not going to. Okay, let's do one or two more. Let's see. Let's do 27 right here. So 27. Let's suppose we had the fourth root of 3x minus 2 to the fourth power. What do you think that is? Is it 3x minus 2, or is it the absolute value of 3x minus 2? They're even, because remember, think, if this is negative, raised to an even power, that has to be positive. And so if you say this, then you're saying it can be negative, and it's not. It has to be a positive. So it would be the absolute value of 3x minus 2. And then 28, if you had the seventh root of 3x minus 2 to the seventh power, see, that's odd. So if that's negative, a negative raised to an odd power is still negative. The seventh root of a negative number is negative. So you cannot put that in absolute value bars, because if you put that in absolute value bars, it makes it positive. So leave it as 3x minus 2. Okay? All right, so that is, and it is not an easy concept. I agree with that. When you first start studying this, it's not easy to deal with, but the more you get involved with this, the more understanding you get. So this is the lesson on simplifying expressions involving the nth root of a to the n.